is going to be, I'll show you real quick. You guys have already built a cone, so this is going to be a little redundant. But this is on aluminum, and I just want to make sure that y'all understand kind of what you're looking for when you're rolling it. So this is part of the assembly. This would be the cone or vice versa, and this is our elbow. And then this would be your squared around. Okay, transition. So they will lay out the cone. It's still the same dimensions that you guys laid out before. It's 4 inches tall. It's a 4-inch diameter to a 6-inch diameter. So it's a reducing cone. All cones are reducing, so they're a cone. But 6 to 4 and then 4 high. Okay. So we would need to know those 3 dimensions before we could lay it out. Okay. And oh, they got here somewhere. Kind of thing. So I just used the corner of this sheet to lay out the cone, and the sizes that I gave you, I think, yeah, 14 by 14, you'll be able to do your layout and get your cone out of that piece. Okay, so you don't have to do the figuring on any other sheet of paper. You can, but you can do everything you need to do right on there. So if we're 6 down here, and we're going to be 4 here, then we want 4 tall. Okay, so you're going to measure over 6 inches. Try to use something that's a little more accurate than that. Big Sharpie. So that would be the diameter. So we're trying to find the true length of that, the hypotenuse of our triangle, essentially, right? Not doing that. So there's 6. You want to come up 4. Okay. Take our square, draw a line over.
Would it be ideal to use a scribe for this kind of stuff?
Sure. Yeah. Problem is when it gets scratched like this, it's hard to tell where your scribe line is and where the scratch is. Okay, so we're 6, 4 up, and then we're going to measure 4 over. Okay. And then we connect those lines, right?
Right.
So we have this point here, and this point here. Then I'm going to draw a line through those all the way till it meets on this edge. Okay, and that's going to give you your dimensions for these measurements. Okay. So I've already got that line drawn on there, if you can see it. But it ends right here, and it goes through this point. And this point. So this is just a little homemade scribe. You can set this at that distance. You guys can use this if you want.
You moved it.
Man.
Is that a relatively easy thing to make?
No.
No. For us, no. For John, yes.
10 minutes at
Can't really
tops.
answer that question. Anyway, center punched just a random spot here. I drew a line from that center punch all the way through, so that would be the start of our cone. Does that make sense? So there's our long dimension. So just set that, center punch it, and then scribe an arc. Okay, that would be essentially your 6-inch diameter arc. Once we roll it, it's going to come around. Okay? And you can do the same thing to set this other distance. So there's our 4 up and 4 over. And set our scribe to that as well. And scribe that one. Does that make sense? I think you guys all did it. Okay. So just kind of a recap on that. Okay, so this is the beginning point. There and there. So now how do we figure how much distance we need to cover around this arc? Let's do that.
By the number of wells.
No, that's your elbow, remember?
Oh, yeah.
Where you have your miters coming together. So think of this.
Don't you divide by your circumference?
Yeah. Think of this arc as your stretch out. Whenever you guys are doing your other layouts and it's all straight line, it's the same thing. So we're still gonna figure out what the circumference is around 6 inches. So 6 times pi is 18.84, I got it written on here, we'll start with it. Okay. And you can divide that by however many sections you want because we're rolling it. If we were gonna form it like Patrick did, we definitely wanna lay out how many bends that we're gonna do, so we know where our degree, how many degrees we need per bend. Okay. But this we'll just stick with the 12 sections because that's been kind of a common division that we've been doing on all our layouts. So we'll take 18.84, which is our circumference of 6 inches, the distance around the circle, divided by 12 sections is 1.57. Okay. Now 1.57, you gotta understand, on this it's really hard to explain because it's such a small cone. If this was a giant cone, we'd have a arc like this. You guys know what a chord is in geometry?
Yep.
Okay, it's a straight line connecting 2 points of an arc or radius. Okay, you don't want this measurement, you want this measurement, right? That's our circumference, so it's no longer a straight stretch out like we did on the elbows and on your other stuff when we were doing that layout. This is on a curve, so you got to make sure that you're measuring 1.57, that's the distance of each section, times 12, on a curve, okay? And it's almost, if you measure on a straight and on a curve, it's almost exactly the same. It's hard to explain that with something this small, but it's not a straight measurement, it's that, okay? You guys understand that? Okay, so you wouldn't want to set your compass at 1.57 across here. You're going to want to measure 1.57 on this arc, and then you can set your compass to wherever that ends up. But it's actually pretty close to the same, because this is small.
So would technically then a diameter be a chord?
What's that?
So would the diameter of a circle technically be a chord?
No, chord's going to be anywhere
But-
along this circle.
You can, it could be.
I mean, if we really, really want to get technical.
A chord is part of it.
Okay, so I take this little fancy bendy ruler, and 1.57, what's that close to?
1/2,
What's it closer to than that?
17 seconds.
Closer to, so,
9/16.
yeah, 1.5625 is 9/16, so it's actually slightly larger than 9/16. And this is where you can get in trouble, because if we didn't measure this exact, whether we measured it too small or too big, you're going to multiply that by 12, so it's either going to get shorter as you go or bigger as you go, and which is what ended up happening to me on this inside one. I'll show you. But you're basically going to swing this arc all the way till it comes out to here. Okay, so we got your circumference divided by 12, and these are our 12 sections. You guys all remember that?
Yeah.
So this one terminates right here. Now in theory, I can draw a straight line from this point to my center point that I started with, and that's going to be my cut line for my cone. I can double check what I did here by laying out the inside one as well, or you could lay out the inside one too. Either way, this point where this one ends at 12 sections and where this one ends at 12 sections, they should all connect in a line to that center point. This one didn't. This one ended up a little bit big. It came out for the 4-inch diameter circumference. It's 12.56. Divide that by 12 is 1.046. So what's that close to? 1.04.
Is it a 16?
Yeah. That's good. And if you don't know, so say you don't know the decimal place for 16. Do you know the decimal place for a quarter?
0.25.
What's half of 0.25?
1.25.
1.25? What's half of 0.125?
1.625.
there's a 16th. So you don't always have to know by memorization what they are, but go off what you know. So you know you only know a half, 0.5. Okay, well, what's half of 0.5? 0.25. You can keep dividing it down to get to where you want to be.
You can also find the fraction on a calculator.
Sure, you can use calculator. That's not fun.
It's faster.
But it's like sense.
It's actually not faster. Once you do get them memorized, it's faster to do it.
True enough.
So I actually did this closer to 1 1/16 and it ended up a little bit big. So if I went to 1.04, which is almost a 30-second less, it should come out closer to where I did it. Does that make sense? Because I'm doing it wrong 12 times. And again, this is just kind of a double check. So no matter how it comes out, as long as you double check it, you should be pretty close to the ballpark. And what's nice about sheet metal work is if you're off a little bit on stuff like this, typically what you can do is bring material in or flare it out. So if you're off a material thickness on your math, if you got off, you're wrong. So you can see that how far off it is from the first time I did it to the second time I did it, and that wasn't even a 30 seconds difference, so it adds up.
Yeah, pretty dang close.
Does that make sense how that kind of worked? And so that's lining up a lot closer to my center line right there. Okay. So if I draw a line through this ending point to that ending point, and from this starting point to that starting point, that should be my cut line for my cone. And hopefully you guys all did it that way when you did your first cone. If not, then make sure you do it this time. So that brings up another point. I kind of gave these guys a hard time just a second ago, but if you're not here for a demonstration, I mean, I do them for a reason. If you're not here for a demonstration, at this point we have most of everything filmed up to this point, so it doesn't make any sense to start on your final project without going on canvas and at least watching the video at some level to understand what you need to be building instead of guessing. Okay? So if you're not doing either of those, it makes no sense to start on something if you don't know what you need to be doing. So, and I don't mind saying things over, but when I don't need to say things over, then I don't. So now you just need to cut this out on the bandsaw and we'll
Yeah, here you
got our speed set right.
I like the spooky sound effects going on with it.
Aluminum's going to cut a lot easier, obviously. So, in theory, this center point should move. Once it's in line with your bandsaw, that's what the cut's at. cut your ends off. Diameters end up right. You guys roll yours out of steel. I'm confident you guys all know at this point that aluminum's softer than steel.
Yeah,
So you
I'm
wanna
betting
make
that's
sure-
way easier to bend, isn't it?
Well, yes and no, so it's gonna wanna gall a little bit more.
Yeah, I feel
than
like it's gonna be way easier to mess up.
it's gonna be, well, it's gonna kinda wanna stick to the rolls a little bit more.
Okay.
So it's softer, it's gonna roll easier as far as how much pressure it takes, but it might wanna stick. So WD-40 can help
That's what I was about to ask.
that, but just make sure you clean up. And it doesn't take much, just a little mist on there. If you're finding it's kinda sticking on you, I'm not. So there's actually two different ways. This is called a slip roll. This isn't a pinch roll. Pinch rolls will actually come down on your material and bite into the material and feed it through the other set of rolls. These aren't that type of rolls. These are called slip rolls. So there's always a little bit of gap between all of the
Little give.
rolls. So basically what puts the tension is you got this beginning and ending roll, and then this top one pushes down between those, and that's what creates the roll. So this is called a slip roll. We have these.
So that helps it from changing metal thickness? Help reduce, like the pinch roll would might?
So slip rolls are ideal because they're more user friendly. So if you don't use them every day, they're easier to kind of set up and just keep going on. Slip rolls, you have to have them dialed in perfect. And the theory behind or a pinch roll, sorry, the theory behind a pinch roll is once you have it set and you can kind of pre-roll your ends, you can run it through and you're done. So you guys remember how many times it took you to get this to where it needed to be? Okay. Now the problem, when we're bending material, whether we're using the pipe bender, the press brake, the hand brake, or roll, if you were able to do this in say 5-6 shots, so 5 passes through there, and the next guy took him passes, your guys, from guy number 1 to guy number 2's ending settings will be different. So the more you bend material in one shot, the more it's going to move. That kind of makes sense? But we can't do this in one shot. So pinch rolls are cool because we can do this in one shot. But since we can't with a slip roll because it does slip and we can't get enough traction to push it through that tight of a turn in one, we got to go through over and over and over to keep adjusting. But just because you did yours in 6 and you ended up, this was at that distance and that was at that distance to get this to come around 360 degrees doesn't mean he's going to end up using those same settings because he might put it through 8 times instead of your 6, and then you're essentially bending this material a little bit less every time, and that affects the overall outcome of how that material comes out. So same thing on a press brake. If you bent it 90 degrees in one shot, or if you bent it 30, well that wasn't right, and then adjust a little bit more and bent it, well now it's at 60. Well now I'm going to adjust a little bit more, well now it's at 90, but it took me 3 tries. Well that setting that you found to get it 90 is not going to be the same setting that you would have for 1 try to get it to 90. It's kind of weird how material works that way, but that's how it does. So just be aware that everybody might end up with a little bit different. So with these slip rolls, you can angle this back roll up and down. You guys notice these are kind of independent of each other. This one comes down, this one doesn't until you turn it. That's a great way to roll a cone because obviously this is a smaller circle than this. honest, right? So if you can taper these cones to where they're closer on this end than this end, you already have that shape halfway there. Does that make sense? Okay. The only downside to doing it that way is you're always going to have to roll the cone in through the same direction. You can't spin it around because now you're counteracting what you just did. So that's the downside to it. Okay. And the upside to it is I can really drive this one up, drive this one down, and I can start way here on this end and roll it through once. And as I move it down every time, I actually don't have to go through and readjust my settings because it's going to naturally get tighter because of that taper. But the downside again is you can't do this with it now.
So is that how you would use it if you were kind of by yourself on this?
Yeah, typically this is how most guys will do it. And because it does, I don't know if you guys noticed when you rolled your cones, we didn't taper these rolls before, right?
No.
We did them all straight. So you'll notice when you're doing them straight that the smaller diameter ends up being not quite there. And the bigger diameter ends up going over. And that's because these are parallel, they're not tapered, because your cone's tapered.
Yeah.
So this does help. You don't have to do it this way, but I'll show you how to do it that way. And if it works for you, fine. If not, you guys have already done it the other way. Okay, so again, just to recap on this, I know you all did this, but you're kind of looking to find a parallel or a perpendicular angle between both of these radiuses and the roll, right? Kind of like if we were going to put brake lines in it, like Patrick did. If you kind of visualize straight lines all the way through as you're rolling that cone, you're going to want to keep that cone manipulated in that fashion. Straight.
Want me to turn it for you?
All right.
He's proving to us that we can do it so.
It's just kind of a bugger when that handle's heavy, it wants to roll back a little bit. Now we can't turn the roll around, but we can run it through back the other way, and that kind of helps. But you will find it's a little stickier on the aluminum. It just wants to bite into the steel a little bit. And be a little careful with that handle if you are doing it by yourself. You can do it with partners, but if you are doing it by yourself, it is a little heavy. So if you get in here and try to start moving stuff, it could roll on you a little bit.
Drop your fingers in. You need to roll that the other way, bro.
So the nice thing is that's the farthest away I need to be because now I can just keep working this way. Does that make sense? Sometimes if you're doing heavier material, this one's a little tough to do, but instead of this handle sliding out, some slip rolls will have a kind of a cam handle. So you can release that pressure on this top roll a little bit and then put your cone where you need it and then lock it back in. Because when this is 1/4 inch stainless steel, it becomes a little more difficult to, almost impossible. Some rolls also, if they're designed to actually be able to roll a cone, they'll have a wear guide right here to where this inner radius will ride against that wear plate, and it'll just naturally self-align.
Oh, nice.
So you don't have to. Starting to get a little bit of a twist. See that? How this isn't parallel with that. So it actually does help from time to time to run it back through the top side. And then whatever I was kind of doing wrong every time, it'll kind of counteract that a little bit. Because there is a lot of room for error. just keep an eye on that as you go. I'm trying to keep those. And that'll change when you either don't twist it enough or you twist it too much. That's what's going to cause that thing to start twisting. Careful when you start jerking on that thing. I'm kind of moving it around that you're not pulling on it so hard that you're actually flattening out what you just rolled. And then just, if you do taper the rolls, you can do it either way. If you do, just make sure that you're conscious of the fact that you're not going to put it in that way one time. It'll totally ruin it.
So doing that ruin the rollers or just ruin your piece?
Well, we'll ruin your piece, but hopefully you can flatten it out and kind of rework it in there and you'll look at it.
Seems like you've done this a lot now. I felt like it was a lot harder when we were trying to do it.
Aluminum is easier though. And you have a little bit of W40 on there. W40, you have to get all that off before you roll it. Yeah, you don't want to breathe the nasty gas off. So see where they start getting close now? You can start looking at how these play together. See how that's kind of shifting? And that'll be a good indicator of when the... See that? That means, oh, I need to move it a little bit more. Does that make sense? So when they get that close, I start watching those ends. How those ends are coming together. So we did that all just in one shot, right, without having to make any adjustments. Now we could give it a little more. The angle that you have these will kind of dictate. These are actually coming together pretty good, so we've probably got a pretty good angle on that. But if you have that too much or not enough, that'll determine how those two ends are coming together. And then just don't rush it. Don't try to force too much of a roll at once. Because all it's going to do is make it hard to move that thing around in there. Like that. If you do that, just back it off. What's that? Yeah, it would help. But just definitely make sure you wipe it all off. Start going. It does get nasty and greasy.
I don't really want my hands.
Yeah.
Thanks for the offer, bud. Yeah.
So if you look at it now, well, it's actually still staying pretty good. If these were starting to get off, you could adjust the angle a little bit. And then kind of start keeping an eye on, if you do taper them, where along these rolls you are. You know, say you can even put a little mark on there. So if the last time I ran it there, then I might bring it up to the next line or whatever. It's not really an exact science, it's more trial and error. And it will pinch your fingers, so be careful about wearing gloves or anything.
So this is one of those, take skin off and smash your whole finger.
Yeah, I'd rather take a little bit of a cut than running my finger through the hole. And I didn't file these edges, but if you do deburr those, that'll help a little bit. Cuts. So at this point, I'm probably going to measure it. It seems like these always end up a little bit open. So if you pull that together, does that match that? If you go a little bit more, it's a little bit bigger this way than that way. So let's see what we got here.
That looks good though.
Yeah.
That's exact. So I'm going to take that where it's at, and then because it is flattened out a little bit there, once you bring those out to where they need to be, it'll probably lengthen that and shorten that just a touch. So I would just leave it alone, just fit it from there.
Thank you for making my comment.
Really, these little mini
Mini faces.
work pretty good. I like them with the feet on them because when you get them clamped, you can actually sit there and twist them, and they'll move the part around for you. So if you need to work it around a little bit like that to get it where you need it. So if you get one top and bottom, then you got a good start. I'll show you the welding on it here when we do the assembly, so I won't talk too much about the welding. But at this point, you're ready to weld, and if it is off just a little touch, you're always going to have that flat spot with slip rolls because you just have a distance of air in there. It's just an air gap.
So how do you bend it back out? Do you not want us to?
I'll show you.
Oh.
It's easy, especially aluminum, to get that where you need it.
So could you tack it and then just put it back on the roller and feed it all the way around?
I just weld it and do it afterwards.
Oh, okay.
Because the welding's going to kind of move it around anyway, so let it do what it's going to do and then come back and get it where I want it. Good?
Yeah.
So you can do it without W40. If you do use it, just make sure you wipe those down so the next guy doesn't get attacked by grease.
The blueprint or the sketch?
We'll start on the print.
This is the one that's like the elbow.
Okay. Does
Yeah.
it go with the elbow as well?
Yeah.
Oh, it's like you got the elbow. I was wondering, I was like,
Elbow to elbow to squared around.
yeah, I was wondering when we were
It's
doing
the
the
whole
elbow.
frame.
I knew that was the only one.
It's a pretty simple kit. It's just an assembly drawing. So it's nothing specific. Should get it all done in one.
Okay.
If you do taper these, make sure you put them back for the next guy. He doesn't get caught off guard thinking they're parallel and they're not. You should always check anyway, but.
Hi.
Extreme close up.
Cut the box! Cut the box!
What do you need? You don't need any of it.
1,000 groups.
This is, my name's Warren Hurlaw. And this is Jackass.
Hey, dude, so it was pretty fun hanging out with your mom and your sister last night, dude.
Yeah? Why?
I don't know.
Did anybody else show up or?
Only one more. Yeah. I don't think the other three could find out where we were at.
Is it like multiple days or is it just the one day?
7 classes. So, yeah. Yeah,
What did you
they
guys do?
just showed them how to melt stuff, stick it together, play around.
You can't talk about what else.
Yeah. You have to ask them, dude. That's like confidential, you know.
My sister is going to take a laundry room. Something like that.
Oh, shoot, yeah, a little bit, dude. She's fucking... I'll turn the propane on for a minute, let it kind of gas up. Dude, she's all... It's all... Yeah.
That's my sister.
Yeah. And then after she got into it, and like about 2 minutes later, then she's like, oh, well, this isn't as bad as you would, like, meant it to be, or because I was, like, making everything all so, yeah, it was pretty fun, dude.
You're gonna like mess with us. It's funny. What's up? Cody sucks. Oh, who said that?
Jonathan, clap your hands and say cut.
Cut.
You got to do it so that I can see them this way.
Cut.
Thank you, bud.